to continue here, this is the equation I had, mg sine theta minus mu k mg cosine theta equals m times the acceleration in the x direction. Remember, this is for an object on a ramp that has a kinetic coefficient of friction between the object and the ramp. Theta is the ramp angle. A is going to be the acceleration of the object down the ramp, and m, of course, is the mass of the object. So the next step, I just swapped both sides of the equation here, and I factored the m out, so it's m times g sine theta minus mu k g cosine theta. So if I want to determine the acceleration of an object down the ramp, divide both sides of the equation by m, and you get that the acceleration down the ramp is equal to g sine theta minus mu k g cosine theta. Now this is interesting because what if the coefficient of friction were 0? In other words, what if there were no friction between the object and the ramp? Well, in that case, this would go away because the coefficient of 0 would multiply this term, making that be 0, and you'd be left with ax equals g sine theta, which is what we had earlier when we didn't have friction. So this equation actually makes sense. It's telling us that as a result of the kinetic friction, the object's acceleration is going to be less than it would have been otherwise. This, of course, is assuming that that the angle is steep enough that it broke static friction, so that the object is indeed sliding down the ramp. Okay, that's all I'm going to talk about regarding ramps and friction.